Today's lesson is going to be about writing your inequality statement. So, looking at some words and telling me should it be x is greater than 5 or x is less than or equal to 5. Because we're eventually going to start writing, taking word problems and writing whole equations. Okay, that's what we're going to do some of today. So, you should have 2 pieces of paper. You got your lesson 19. That's your notes. Okay, that's going to be what goes back in unit 2. These are the pieces of paper that go with this activity. So, your directions say, cut out each square, read the problem, and separate into categories. Now, I already have your categories set up for you. You're going to cut these out, and you're going to figure out if each of these belongs to a less than or equal, an equal, a greater than, or a greater than or equal. You are not going to glue or take them down yet, because you got to make sure you got them in the right spot. Now, let me tell you the fastest way to cut this. You're going to trim off the edges and just ball it up. Then, cut it into strips, stack them jokers up, and go chop, 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 chop. Alright, to the next one. If I can grab hold of it. See, this way you got to be careful. I just dropped it. Alright, I need fewer than 20 minutes to get ready in the morning. So, fewer. Does that mean I need less or I need greater? Fewer means I need less. If I need fewer than 20 minutes, do I include the 20 minutes? Nope, I need under 20 minutes, so less than 20 minutes. So then I grabbed, Gabby needs 3 cups of sugar. Well, how much sugar does she need? Exactly 3 cups, so that's going to be equal. Okay? You must be taller than 48 inches to ride the roller coaster. Now, if you have to be taller, if you're exactly 48, are you going to be able to ride? So, if you put it right here, that would mean only people equal to 48 could ride the roller coaster. If you have to be taller, are you going to be less than or greater than? What if you are only 48? But I have to be taller. So I have to be greater. Now, if it had said you have to be 48 inches or taller, so I can't be exactly 48. All right, this next one says, the elevator can hold at most 200 pounds. Now, let's think about that. The most the elevator can hold is 200 pounds. So, can it be 200 pounds? Yes. Can the elevator go over 200 pounds? Why not? It can't hold that much. It's going to break. So where had you better stay? 200 or less. So 200 or less would be less than or equal. All right, so the next one I grabbed, it says the temperature is at least 90 degrees. Now, at least implies that the lowest it could go is 90 degrees. So if you're at your lowest of 90, where's the only place you can go from there? Up. So this is saying that the temperature is 90 or over, so that would be greater than or equal to 90. All right, so the next one I grabbed says the essay must be more than 200 words. So if it's more, is that going to be less or greater? It's going to be greater. So I narrowed it down to right here. It has to be more than 200 words. So what if it's only 200 words? It don't count. It's got to be greater than 200 words. So 201 words is fine, but 999 ain't okay, and 200 isn't okay. All right, so then I grabbed Deacon is 6 feet tall. You see less than, equal, or greater than? Equal. He's exactly 6 feet tall. All right. You must be older than 12 to drive a go-kart. So if you're older, are you going to be less than or greater than? You're going to be greater. So I narrowed it down to this side. If I have to be older than 12, what if I'm 12? Then you're not older, you can't. So it has to be greater than 12. All right. I grabbed the statement. I need 30 minutes or more to get ready in the morning. Greater than or equal to. I got to be at 30 or half more. So that's greater than or equal to 30. The restaurant can hold up to 100 people. So if I can hold up to 100 people, that's the most I can have. So if I can hold up to 100, I can't go over, so I better stay under. Now, so I got to say on the less end. Can it hold the full 100 people? So you would say less than or equal to 100. Now, if you're using tape, you could tape each one down individually. You could wait till the end, or I'm going to take a piece of tape like this long, and you can't hover it because you know what's going to happen. Static electricity is going to pull it to it. You got to be kind of quick, and you could go ahead and tape a few down. That way, if, for us, in case we move our paper, we don't want them to go everywhere, okay? So I'm going to go ahead and tape down what I got. It might make my paper, see how it's going to pull up a little bit? It is what it is, okay? So the glue won't make your paper roll up, but I know the tape ain't going to let my papers go off either. So let me fix these real quick because I don't want to knock them over. All right, so now I'm going to keep going. All right. The next one I picked up says that Julia has 6 horses. Is that greater than's, less than's, or equal to's? She has exactly 6 horses. All right, she's equal to 6 horses. All right, children under 3 get in free. So if you have to stay under 3, are you less than or greater than? Okay, so what about those kids that are exactly equal to 3? Are they under 3? So it has to be less than. Can't have had your 3rd birthday yet. Is what that's saying. All right. The weight limit on the bridge is 70,000 pounds. If that is the limit, that is the highest you could go. And a lot of students are going to say greater than. But you got to think about, if 70 pounds is the highest you can go, what's going to happen if you go greater than 70,000 pounds? The bridge is going to break. So you better stay less than. Now, could it be exactly equal to if that is the limit? Yes. So the limit, it means it's the highest you can go, so you better stay there or under. All right. Alex eats at least 2,000 calories every day. When Alex eats at the very least 2,000 calories, that's the lowest he can go. So from there, he's going to go up. So that would be greater than or equal to. All right, so then I grabbed the kitten weighs less than 3 pounds. So what's that going to be? That's less than. What if the kitten weighs equal to 3 pounds? No, that says the kitten weighs less than 3 pounds. All right. You need to be 16 or older to drive a car. So your limit is 16. From 16, are you going up or down? Up. Now, so it's going to be greater. Can you be exactly equal to that 16? So that is or equal to. Greater than or equal to. Miguel read more than 150 books. So was he less or was he greater? All right. Did he read equal to 150 books? Nope, he went over. So if he just straight up went over, that's greater than. You must be 36 inches or taller to ride the roller coaster. So if you're going to be taller, that means we know we're greater than. Can we be equal to 36 inches according to this? Yeah, because you can be 36 exactly or taller. So it's greater than or equal to. And then the last one I've got says the speed limit is 70 miles per hour. Now, I'm not talking about how you drive. Somebody this morning told me, oh, well, that's going to be greater than because I drive greater. It's about what you're supposed to do. A speed limit tells you this is the most you're supposed to go. And where are you supposed to stay from there? You're supposed to stay there or under. This is the maximum you should go. So you're supposed to stay less than or equal to your speed limit. All right? So take a few minutes now and finish either gluing down or taping down all your pieces up. All right. All right, so now that we have figured out how to tell if it's going to be greater than or less than, greater than equal to, less than or equal to, we're going to use that skill combined with our skills for writing equations, okay? Now, look at this one, okay? For example 1, what you're going to do is you're going to basically, this is stuff that you figure out when you go shopping. You have to calculate in your head. Now, you don't set up an inequality and solve it, but you could, all right? It says Juan has no more than $50 to spend at the mall. He wants to buy a pair of jeans and some juice. If the sales tax on the jeans is 4% and the juice with tax costs $2, what is the maximum price of the jeans that Juan can afford? What is the variable that you don't know, that you're trying to figure out? All right. So your X is the price of the jeans, okay? So that's what you don't know that you need to know for Juan. Juan has a limit. What is Juan's limit, his total? $50. All right? So what he has to spend, what he spends can be no more than $50. So if it can't be more than 50, what does it have to be? Less than. Could he spend all 50? Yes. So you got to figure out how does he spend his money, and it's got to stay less than 50. All right. So this one is tricky if you're not familiar with taxes, okay? So Juan is going to buy the juice. So it must be some real good, you know, like that boba drink stuff, okay? And he already spent $2. Then he's going to go buy his jeans. Well, how much money is he going to spend on one pair of jeans? Up to $48. All right, so you're common sensing it, and that's fine. You can totally figure this out with common sense. He's got up to $48. So how much is he going to spend? You say, I don't know. It's X. Now, he bought the juice, so he already took his $2. He bought the jeans. But every time you go, you have to pay sales tax. Does sales tax add to your total or subtract? It's going to add to your total. Now, wherever he's at, he's only paying 4% sales tax. That is going to be 0.04 for every dollar he spends on his jeans. And what was the price of his jeans? X. Okay? So, pay for his juice, pay for his jeans, this pays for the tax, and altogether he better stay less than or equal to $50. Why does he have to stay less than $50? That's all he's got. If he wants to go in the store and his purchase is going to be like $62, they're not going to just front him the other money because he's cute. Okay? They're going to say, no, sorry, you're going to have to go pick some cheaper jeans or something. All right? So this is how you write your equation. Now, I need to simplify this up a little bit. These are like terms. So you have $2 for juice plus 1x and 0.04. That means 1.04x. It's got to stay less than or equal to 50. This is the jeans and how much you pay for taxes together. Now, that is like having 104% of the cost of the jeans. Okay? You pay for the jeans, you pay a little extra. Now, help me solve for X, which is the price he could spend on his jeans. So what am I going to do first? All right, I'm on minus 2. And so 1.04x less than or equal to that 48. So that's what she was saying earlier. She said he's got $48 left. You could common sense this. If you were in the store, I highly doubt you're going to grab a piece of paper and do some algebra. You're going to get your head, you're going to go 50, take away the 2, that gives me 48 extra dollars I still got to spend. Now, how do I undo times 1.04? I'm going to divide by 1.04. Now, I'm dividing by a positive, so I do not mess with the sign. His X, which is the price of his jeans, has to stay less than or equal to 48 divided by 1.04. which would be $46.15. So less than or equal $46.15. So if he finds a pair of jeans he likes and they're $48, can he get them? Because he's got to allow for taxes. What if does he have to buy a $46 pair of jeans? Could he find a $22 pair and buy those? Yeah. Okay. He just can't go over because he won't have enough money. So he's got to stay less than or equal to $46. All right, example 2 says, Alexis is saving to buy a laptop that costs $1,100. So far, she has saved up $400. She makes $12 an hour babysitting. What is the least number of hours she needs to work in order to reach her goal? So, what is she trying to figure out? What's her X? How many hours? So the number of hours that she is going to have to babysit. Now, what is her ultimate total here? What does she need? She needs her money. And how much does she need? All right. So, the computer is going to cost her $1,100, right? What's going to happen if she has under $1,100? Can she get the computer? Okay. So where does she have to do? She has to save money until she gets greater than or equal. So I guess I shouldn't write computer. I should write money saved. Money saved. Because she's saving up money to get the computer. All right. Tell me what you know about what Alexis has already got saved up. She's got $400 already. Now, she's going to add to that her babysitting money. And how much money is she going to get for babysitting? $12 for every hour she babysits. And then she needs that to be greater than or equal to $1,100 so she can buy her computer. Now, I know you might be thinking, what about taxes? I'm assuming Alexis has done figured out the taxes as well. Because you know when you go, you got to pay taxes. So, I need to know how many hours she needs to babysit. So, what are you going to do to start solving for X? You're going to subtract 400. 400 minus 400 goes away. You've got 12x greater than or equal to, what is 1,100 minus 400? 700. All right, so now here's what this really means. She needs 1,100. She's already got 400. She needs to babysit enough hours to get at least $700. So she needs another $700. She's going to divide that up into $12 for every hour. Now, $700 divided by 12 hours means 58.3 hours. Now, let's be honest. Y'all know how babysitting works, all right? If she's at work, is she just going to be like, deuces, that's my 0.3 of an hour. I need my money so I can go get my computer. No. You got to figure out, does she need to work that whole hour or could she just stop at 58? So, I got to check this, all right? If she has $400 plus she makes $12 for every one of 58 hours, does she have enough money to buy her computer if she only babysits for 58 hours?
No.
Why?
Because she needs $3 more.
She's short by $4, okay? Now, she's not going to go into Best Buy and be like, I'm short $4, and they say, oh, you so sweet, here's your computer. They're going to say, well, come back when you earn $4 more, okay? So, if you're babysitting, you don't usually leave right in the middle. You stay the whole hour. So, what she would need to do is work a 59th hour. Because if she works that 59th hour, does she have enough money? Yes. So, our everyday knowledge tells us that we're going to tell her, Alexis, you better work 59 or more hours if you want to get this computer. Example 3. So as I read this, I need you looking out for what is my variable, And what is the total that I'm going for? Jonah subscribed to a new service that streams music over the internet. The service costs $2.95 per month, but Jonah's rate is reduced by 15 cents for each new subscriber that he gets to sign up. If there is no limit to the discount, how many users must Jonah recruit in order for him to listen for free? Now, what do you not know that you're trying to figure out? They straight up ask you how many users. That's your X. So X is going to be the number of users, or the number of people he recruits, the number of people that he gets to sign up. So you know when you have a service or whatever like that, and they say, share this with a friend to get $10 off, or whatever. That's what they're saying. So people go on their social media and they share the link. Well, when somebody clicks that link and they sign up, Jonah gets the discount. That's what this is saying. Now, what is his total? What's he trying to do? To listen for free. So how much does Jonah want to pay? He wants to pay $0. Now, is he trying to get like exactly equal to 0 and stop people from signing up? No. He just wants to make sure he pays less than or equal to $0. When you write the inequality, you don't have to write these words. I'm just writing it so we know what we're figuring out. So what Jonah wants to pay needs to be less than or equal to $0. So let's write that equation. What does Jonah start out paying? $2.95 for the month. But then he's reduced by 15 cents every new user. Now, if I reduce, am I going to add, subtract, multiply, or divide? I'm going to subtract. Now, watch what I'm about to do, and what I'm about to do is wrong. There's going to be people that says 15x. This is $2.95. If you don't put the decimal, what are you telling me this is? $15. If that's the case, all you need is one person to sign up, right? But it's not. It's 0 point. You got to make sure that 15 cents matches the format of any other money. Now you got your equation. Or that's not an equation because that's an inequality. You need to solve for X. And when you find X, you're going to find the number of users Jonah needs to get to sign up for him to pay 0 or less dollars. So if I want X by itself, how do I get rid of positive 2.95? You got to subtract. Now, I notice that's a negative. Listen carefully to the question I'm about to ask you. Oops. Do I need to flip that sign because I subtracted? No, because what's the only time you flip a sign? Very good. If you multiply or divide by a negative number, okay? I still need X by itself. So over here is negative 0.15 times X. What is the inverse of times that stuff? Divide. And so I'm dividing by negative 0.15 on both sides. And immediately, that's my red flag right there. When I divide both sides by a negative, I'm going to flip the sign. And what I mean by sign is, I'm going to flip the inequality sign. I just didn't write the word inequality. So less than or equal to becomes greater than or equal to. So your X, your number of users, must be greater than or equal to negative 2.95 divided by negative 0.15. Can you convince 19.6 people to show up, to sign up? No, you can't have 0.6 of a people. So what you got to do is you got to figure out, is 19 enough or do I need to go to 20? So 2.95 minus 15 cents for 19 people. He's still going to have to pay 10 cents. 10 cents cheap, but is that free? So he needs to get that 20th person because now they owe him 5 cents. So common sense logic tells us he's got to get greater than or equal to 20 people to sign up if he wants to get that month for free.